Hi all. Today we are going to see about how to query your database using high-level natural language. Basically, the user's input will be or your input will be in English, and the output will be the result from the database. If you want to ask, the use case would be like if you want to see for example, you have the data of companies and their performance based on the year. And if you ask the questions like, what is the top 5 companies which is performing good last year? Then basically this query will be converted into an SQL query. That SQL query will be processed in database and the result will be again passed to the LLM so that the LLM will be responding or generating a visualization chart to show you the output. You can understand, right? Basically, your high level English question is processed in the database and it gets back you the answer like a high level English itself. Basically, you are querying your database using English. This is done by a open source library which is available in GitHub. Let's see how we can do that. Actually, I was mentioning about this repository Vanna, where if you see the interaction with the database, right? They are mentioning about you can connect to any SQL database, any vector store. We will see why vector store is needed, any front end, and any LLM. Basically, using any LLM by passing a high level English question, you can interact with your database. So, why is vector store needed here? If you see in this how Vena works, right? Basically, the user asks a question that will be first searched in a DDL schema documentation and the correct answer. So these all will be stored in the vector store. So if the user's query is already more related to the DDL schema or the previously asked question, right? Then it will be easy for LLM to give out the answer what the user expects. Then by information from the documentation, DDL schemas and the previous question answers, it will be passed as a context to the LLM with the user's exact question. So now the LLM will be executing it, and I mean not executing, trying to generate the SQL query, so that SQL query will be executed in the SQL database. So the end of the day, the answer from the database will be passed to the SQL query charts or data frame or plotly to give you visualization. So after visualization, the user can give the feedback of yes or no, is it right or not. So if it is yes, the user question and receive the answer is expected answer for that question, right? Then the user clicks yes, so that will be stored in the vector store. This is the overall plan. Basically, if you see, right, it is kind of RAG only, but this RAG is implemented for accessing your database and querying your database. So this is what they have done. Trained, I mean, they have their own AI also. So like they have already trained with all these information to the LLM and trying to ask the question, trying to generate the embeddings and I mean, basically they are elaborating the process how the RAG process has been done. Like the user, I mean, the question will be converted into embedding searched in the vector store. The vector store response will be again given to the LLM as a context. That context with the LLM will generate the SQL. This is what happening. What they are mentioning is like it is performing good. And if you want to see demos, right, it can be accessed in, maybe I will show you the top demo. This is easy to understand. Like it's easy to import and access things. If you ask some questions, right, then it will actually answer, I mean, so do all these process and give back you the output as it's shown here. It's not only used as a Python, it can be connected with any front end, like already they have mentioned. And also it's not only about front end, it can be connected with the uh, Slack bot also. So if business people want to ask some questions, which is the information is available in the database, right, it can be directly accessed from the Slack and the answer can be retrieved from the Slack. So this is the quite end-to-end flow how Vana works actually. Basically you are performing a RAG search in SQL query to query the database. That's what happening over here. It can be connected with supported. They have mentioned like supported LLMs are like OpenAI, Anthropic, Gemini, all the top models. Supported vector store is also very important. PG Vector, Pinecone, Chroma, DP, Fires. I mean, this is Facebook one. Milverse, Quadrant, VV8. These are all are actually pretty famous one. And supported databases are all like also most of the SQL famous SQL database what we use is available over here. Installation and I mean working out with this is also pretty easy is what I feel. Let's see the demo how it works. Before going into the demo, right? Actually, what I said is like true in the sense of you are using your English language to query database, but does it work with production level database or which has multiple tables, multiple joins, or a very complex database? For that, it can work, but especially you need more examples for that. What type of query your user asks, you must have you will be having already the existing queries what the user have been asked and it has been processed. These much years your product would have been had the sample queries. So now you can use all those queries for using this Vana so that it can able to produce the results so nicely. That's the overall aim of this. Basically, it's not from scratch by itself will perform at a production level database, but using the examples and the samples you already have, right? If you feed it to this vector store, they call it as training, but it is not exactly training. Let's see in the demo. But if you feed it to this Vana.ai, right, it would be able to perform better. It is not 10%, it would accurately say, I mean, give the result what the user need, but at least if you are giving a number of examples to it, for sure it is going to perform good. Let's see the demo. Let's see the demo. If we see it right, let's start with installing Vana like with pip install. Then if we see here, we are just importing the class of Vana. Second, we are using Quadrant for vector store. And this is the model what we are going to use. We are connecting with the Chinhook like for extracting the DDL commands. Basically, what we are doing is vn.train. We said there right how Vana gets processed. Basically, in vector store, it stores the DDL schemas, documentation, and correct answers. We are giving that input now. Basically, we are giving the input, the sample what already we had. Like we are extracting the data from here and passing it as a DDL commands, vn.train. Okay. So it is basically adding up all the DDL commands in vn vector store, and also some documentations as text we are giving as an input, and also some the query which already worked, the correct answers as an input. So if we see the training data, right, vn.get training data, we can see all the data what we have inputted as of now. Now, once if this is done right, the training process or giving the sample as an input, everything is now over. Now let's ask the question. Like VN does ask, give me the top playlist which is expensive. So the system, this is the system prompt. Like you're an SQL expert. This is a system prompt. Create index. So these are all the input which came from the vector store. These may be a documentation or the previous correct answer or also DDL commands. Everything will be as an input over here. So using this, the AI model tries to using GPT 3.5 Turbo 16K tokens. I mean, yeah, this tries to generate the SQL query to hit. If you see, it has multiple joins, order by, group by, everything. So to prepare a complex query, right, then we need this much amount of samples to be input. So this is the playlist name and this is the total price. We can also see it as an output over here. What is the price? What is the playlist name? Everything. So this can be run as front-end Flask application also, but anyways, this can be integrated anywhere. So this is the overall concept. Primarily, what all do you need? You need this library and you need the older samples which you would have already run and got the answers and documentations if you have and the DDL commands. So these are all the primary inputs needed for this library. Once this is done, this library can be easily able to generate the SQL queries Based on that, the query will be again as shown in the diagram, will be passed to the LLM to answer, and the LLM's answer will be executed in the database. Basically, the database result will be sent to any plotly or data frame to generate the plot, graph, or chart, whatever you needed. So based on the output, that will be shown to the users. The user will be saying, is that correct or not? Is the extracted result is right or wrong? So based on the result, if it is yes, then as we seen over here, right, vn dot train by giving the SQL correct commands. Like this, it will be added, the query which is generated by the LLM. So once the application started getting more users and more queries, right? So the application gets matured and it starts executing and generating more accurate queries. So this is what this Vana tries to do. Basically, get your data or your database schema and the documentation and tries to generate the SQL query and executes it and show it to you. Once the user's questions query, I mean the generated query is correct, then it adds to the vector store. So once the data is getting added to the vector store huge, right, then the accuracy of the generation will be also high. It's basically a timed process. Once the user base increases, your output from your application will also be increasing. I mean, the accurate output from the application will also be increased. This is a small overview on Vana. Let me know in the comments what you think. See you in another video. Thank you. Bye.